Sooner or later, everybody has to take statistics. Well, to be fair, in some universities it's actually mandatory, and in some other it isn't. But if you're watching this, it means that you had to take statistics for a reason or another. So I guess it doesn't matter, does it? Anyway, the reason why I'm here today is to talk about the Poisson distribution. And I could actually tell you the formula, but it doesn't really tell anything. I mean, by the formula per se, because if I write it down, then it doesn't really make much sense. So, as I always do, to explain this, I'm going to use an example. So our example is going to be the following one. A tree. Let's suppose we are in the countryside and we have a tree. This tree is visited by two birds every 3 minutes. So it's a fairly crowded, tree on average. And we want to know what's the probability that four or fewer birds will visit that tree in a 9 minutes period. So we have a certain time constraint. We want to know how many birds, what's the probability that four or fewer birds will visit that tree in a 9 minutes period. So, first of all, let's write the Poisson distribution formula. So the Poisson formula is the following. F, well actually P, what am I doing? P of x lambda is equal to lambda to the x e to the negative lambda over x factorial. So now the formula doesn't really tell you anything, like per se, but everything's going to be clear as I go through it. So what is lambda? What is x? How can I find those two? Well, first of all, let's find lambda. So let's find lambda. Now, we said that we have two birds every 3 minutes. So how many birds are gonna visit the tree in a 9 minutes period? Well, we can calculate that because we actually expect that since we have two birds every 9 minutes, we can say, okay, 3 is the ratio. It's going to be equal to lambda, which is our the thing that we have to find, value that we have to find, with a ratio of 9. So the product of the terms in the middle is equal to the product of the terms on the outside. This is pretty basic stuff. So we have basically 3 lambda. So 3 times lambda is equal to 2 times 9. So 2 times 9. Now, 3 lambda, 2 times 9 is 18. Therefore, lambda is 18 over 3, which is essentially 6, because we can simplify this too. So it would be like 1, 6, so lambda is 6. Now, lambda is, how many birds we actually expect to visit the tree in a 9-minute period, given that we know that on average there are 2 birds every 3 minutes. So after that, we are gonna use the Poisson formula to calculate the probability that we're gonna have 4 or fewer birds in 9-minute period. Now, how do we do that? Well, we're basically gonna have that the probability of having 4 or fewer birds is gonna be, well, lambda, so 6, because we just found lambda, raised to the power of, we're going to start from 0 all the way to 4. So we're going to start with x equals 0, then sum x equal 1, x equal 2, x equal 3, and x equal 4. And we're going to sum all those values, so from 0 to 4. So we're going to have a 6 raised to the power of 0 dx times e raised to the power of negative lambda, but lambda is 6, so e to the negative 6. Everything over x factorial, so 0 factorial. Plus, I'm going to go all the way up to 4 because it's asking us 4 birds. So 6 raised to the power of 1, which is the x, e to the power of negative lambda, which is 6. Everything over x factorial, so 1 factorial, plus 6 raised to the power of x, so raised to the power of 2, e to negative lambda, so negative 6, over 2 factorial, plus 6 raised to the power of x, so 3, e to the power of negative lambda, so negative 6, over x factorial, so 3 factorial. And lastly, 6 raised to the power of x, so 4, e raised to the power of negative lambda, so negative 6, over x factorial, so 4 factorial. Now, we have to work with those numbers to get our answer. So, what do? Well, we compute these things. So a number raised to the power of 0 is just going to be 1. So I'm just going to write 1 e to negative 6 over 0 factorial is 1. So it's over 1 plus 6 raised to the power of 1 is just 6 e to the negative 6. 1 factorial will be 1 times 1, which is 1, plus 6 raised to the power of 2 is 36, e to the power of negative 6, over 2 factorial is actually 2 times 1. I could write just 2, but just to let you memorize it. I mean, you should be pretty familiar with factorials by now, but still. 6 raised to the power of 3 will be 36 times 6, e to the power of negative 6 over 3 factorial, which is 3 times 2 times 1. And lastly, we would have 6 raised to the power of 4, which is 36 times 6 again, e to the negative 6 over 4 factorial, which is 4 times 3 times 2 times 1. And we go on. So P is going to be, 1 over 1, just 1. So times E is going to be e to the power of negative 6 plus, same goes for here, so 6 e to the power of negative 6 plus, it will be 36 e to the power of negative 6 over 2, but we can simplify this. So this becomes a 1 and this becomes an 18. plus, well, this one, 36 times 6 is 216 e to the negative 6 over 6. We can simplify this once again, so this becomes a 1 and this becomes a 36 plus this one will be 216 because I just computed it here, times 6 again, e to the negative 6 over 4 times 3 times 2 times 1 is 24. And we go on. So P is actually going to be, well, e to the negative 6 plus 6 e to the negative 6 plus 18 e to the negative 6 plus 36 e to the negative 6 plus, well, this gigantic mass will be 1296 over 24, but well, e to the negative 6, but actually I could simplify the 6 with 24 and then divide it, so this one becomes a 1 and this one becomes a 54. So we go on, and what do we have? Well, we have e to the negative 6 plus 6 e to the negative 6 plus 18 e to the negative 6 plus 36 e to the negative 6 plus 54 e to the negative 6, and we go on. Now what do we do? Well, we do know, I don't actually like to have a negative exponent here, e, a number, then e to the negative 6, and we can easily simplify saying that, well, a, which is a number, scalar, raised to the power of a negative value is actually like saying, okay, is 1 over the very same value raised to the positive. So in this way, I'm going to use this simple algebraic property to basically rewrite this and write it as 1 e to the 6 plus 6 e to the 6 plus 18 e to the 6 plus 36 e to the 6 plus 54 e to the 6. Now that I've done it, e is actually around 2.7, so I'm gonna write it again as 2.7, so 1 over 2.7 raised to the power of 6 plus 6 over 2.7 raised to the power of 6 plus 18 over 2.7 raised to the power of 6 plus 36 over 2.7 e to the power e is 2.7 raised to the power of 6 plus 54 over 2.7 raised to the power of 6. Now I know the mathematicians among you are saying, oh no, e is not 2.7, and yes, you are right, but I'm approximating and I'm rounding up, and it's fine in this scenario. So 2.7 raised to the power of 6 is actually 403.4, so 403.4, and I'm gonna rewrite it as it is, so 1 over 403.4 plus 6 over 403.4 plus 18 over 403.4 plus 36 over 403.4 plus 54 over 403.4. Now P is actually equal to, and we're actually getting really close, because now we just have to compute this simple thing, and I'm basically gonna sum all those terms. So 403.4 So we're going to have 1 plus 6 plus 18 plus 36 plus 54. So P is, well, is the numerator is 115, given by this sum over 403.4. And I'm going to get a calculator because I don't actually know how much 115 over 403.4 will be. But I guess it's, yeah, it's actually around 0.285. And if since it's going to be a percentage, I multiply that by 100 and I get that the probability is 28.5%. So a quick recap to get this. We have our problem, which was saying that a tree is visited by 2 bears every 3 minutes on average, and was asking the probability that 4 or fewer bears will visit the tree in 9 minutes period. So to use the Poisson formula, Poisson distribution, what we do is first to find lambda, which is our expected number of bears that are gonna visit the tree in a given period, so in 9 minutes, given that we know that 2 bears visit the tree every 3 minutes, and we found it. And then we applied the formula. We said, okay, how many bears do what actually is the probability that 4 or fewer bears will visit the tree? I mean, how many bears for how many bears do you want the probability for? And it was like, okay, 4 bears, so we're gonna have and sum all the value for x equal to 0 up to x equal to 4. Please note that it's very, very important that you do include x equals 0 and you don't start from x equal 1, because otherwise you're not going to get the same percentage. So remember, from 0 all the way up to the number that the problem wants, basically. I'm going to sum all those values applying the formula. And then it's just a tedious work, like algebraic work, to just get the percentage and then the final number. So yeah, I mean, Poisson distribution is actually simple, to be fair, but it's not. Sometimes professors don't actually explain it this way, like with an example, and I do think that it's actually confusing a lot of people because of that. Because professors don't actually start with an example. They start from theory, and sure, I could have done the same, but I wanted to take a different approach. So I don't know whether I'm gonna make another video. Probably yes. Probably another. I'm gonna make another example. Definitely not today. Maybe tomorrow, I think. Anyway, I hope, as always, I hope it helps, and cheers.